Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. And today, we'll be continuing with our financial mathematics series. And we'll be looking at nominal and effective interest rate. Take note, this is part 14. Make sure to check out all the other parts prior to this part. These could be beneficial, especially in understanding the concepts covered today. As you may recall, in the previous sessions, we have been looking and working on nominal interest rate, which is a stated and simple annual rate. So all the R's that we have been using in the past refer to the nominal interest rate. However, the effective interest rate, EIR in short, is the actual higher rate that accounts for the compounding interest within a year. And recall from video part 5 and 9 in this series, Financial Mathematics. Make sure to check it out. You might benefit a lot out of it. The FV was given to be P times 1 plus R over I. And take note, we are no longer using R, but we are saying that was R norm, which was for the nominal interest rate, raised to the power NI. And let's label this equation 1, where FV is the future value, P is the present value or the principal, R norm, which is the nominal decimal interest per annum, and N is the number of years. I is the number of periods in a particular year. Note, when using the effective interest rate, REFF in short, the future value FV is given to be P times 1 plus REFF, or the effective interest rate raised to the power N. We are going to label this equation 2 for ease of reference. Now that we have two formulae that we have, one based on the nominal interest rate and the other one based on the effective interest rate. In order to derive the effective interest rate in terms of the nominal interest rate, when N is 1, that is to say within a year, we can actually find the relationship between the nominal and the effective interest rate directly. So we are going to equate equation 2 to equation 1, since they give us the future value, implying that if we were using both formulae to find the future value, we would get the same future value. So if it is the same future value, it means that equation 2 should be equal to equation 1. So with that in mind, we are going to have that equation that we have. So from this equation here, we see that we have something that is common in between the two sides, the left-hand side and the right-hand side. We've got a P multiplying the other terms. So what we do is divide both sides by the P's. So what we do on the left-hand side is the same thing that we do on the right-hand side, for those who may not be used to dealing with equations. So remember, the point of numbers simplified is to simplify each and every mathematical numerical problem. So dividing throughout by P, we are going to have 1 plus the effective interest rate is equals to, in parentheses, 1 plus the nominal interest rate divided by I raised to the power I. So with that, we can subtract 1 from both sides, and if we do so, we end up having the effective interest rate being equal to, in parentheses, 1 plus the nominal interest rate divided by I raised to the power I minus 1. And let's label this equation 3. So this would be easy for us to reference if it is labeled. Great then. So now that we have what the effective rate is in terms of the nominal interest rate, we can also find the nominal interest rate in terms of the effective interest rate. So let's consider from equation 3, we can actually rearrange the order so that we start with the nominal interest rate part on the left hand side, since we are trying to make it the subject of the formula, and we have the effective interest rate on the right hand side. So we start by adding both sides because we are trying to make the nominal interest rate be the subject of the formula. So adding 1 on both sides, we are going to have 1 plus nominal interest rate divided by I, all raised to the power I, is equal to the effective interest rate plus 1. So the next thing is to take the ith root on both sides. And if you don't understand what this is all about, I encourage you to check out our indices video, for we cover such concepts. Now, taking the ith root, we are going to have that bit over there. So what we do on the left hand side, we always do on the right hand side. That's how we deal with equations. So now this would remove the ith power on the left hand side so that we have 1 plus the nominal interest rate over I being equal to 1 plus the effective rate raised to the power 1 over I. That is the same as saying the cube root of 1 plus effective rate. So the ith root, to be precise. So it is actually the ith root, not the cube root, but the ith root. Great then. So now with that, we can now shift the I to the other side by subtracting both sides by 1, so that we have the nominal interest rate over I being given by that. So of course, the next thing is to remove the I. We clear the fractions by multiplying both sides by I. So in doing so, we are going to end up having the nominal interest rate being equal to I times in square parenthesis and in curved parenthesis 1 plus effective interest rate raised to the power 1 over I minus 1. So that is one way of doing it. Or we expand the square pair of brackets or parentheses so that we have the nominal interest rate being I times 1 plus effective rate raised to the power 1 over I minus I. And let's refer this to equation 4. So by equation 4, we are referring to the first formula and the latter formula. So we can use both of them interchangeably because this is basically the same formula. Now that we have reached thus far, let's take a look at some examples. Taking a look at example 1 now. A nominal annual interest rate of 5% is compounded weekly. What is the effective interest rate? So before we try to think of which formula to use, it is always important that we first identify each and every variable that we're given. So we know that we have the nominal interest rate, which is 0.05 in decimals, but of course as a percentage that would be 5%. Then we're told that this is compounded weekly, so implying that within a year we get the number of weeks, which is 52. So our I becomes 52 because that is the number of times it is compounded within a year. So what we are looking for is the effective interest rate. So with that, we see that formula 3 is the relevant formula to apply. So we take that formula, and that is the formula right there, formula 3. The next step is to substitute for the variables that were given. So we know that the nominal interest rate is 0.05, so we substitute for that. And we see that the I is 52, so we are going to substitute I with 52, and that is in two places. With that then, the next step is to make sure that we deal with what's inside the pair of brackets or parentheses. Before we continue with that, if we have fractions, like in this case, 0.05 divided by 52, we may want to know what this is in a simplified manner. We see that that becomes 0.00096. Great. Now we can move on to add what's inside the pair of brackets or parentheses before we deal with the powers, because each and every step is crucial. That's one. The second thing that we have to note also is the number of decimals are important. And I encourage you, if you are going to simplify your work, if you're going to evaluate whatever you have, make sure to go as far as 4 or 5 decimal places so that you don't compromise a lot on the particular accuracy of the question. Right, so with that, we are going to add what we have inside the pair of brackets or parentheses so that we have the effective interest rate being 1.00096 raised to the power 52 minus 1. Then the next step, of course, would be to compute what this is. So computing that raised to the power 52, we are going to get 1.05116 minus 1. And of course, this is easier to simplify so that we get our effective interest rate is 0.05116 in decimals. Therefore, as a percentage, we get our answer as 5.12%. And that's how we get the answer to this particular example. Moving on to example 2. A bank charges nominal annual interest rate of 6%, which is compounded every 2 years. What is the effective interest rate? So, as before, we look at what variables we are given from the question. So it's easy to see that we are given the nominal interest rate, which is 0.06 in decimals. And of course, that means 6%. And the I, take note of this particular I. It happens in every 2 years, implying that a single year has half of what we would need or what would be compounded. 2 years is just one compound. So 1 year is half of that. Therefore, our I becomes half or 0.5. Great. So we see that we are looking for the effective interest rate, given the nominal interest rate as well as the I. So equation 3 would be ideal. Right, so equation 3 is that, and substituting for the nominal interest rate, we are going to have 0.06 in place of our norm, and the I, we have 0.5 in 2 places. So we check to see if we have substituted for everything that we have to substitute for before we proceed. And it seems we have. Then we deal with the fraction which is within the brackets or parentheses. So that fraction over there, 0.06 divided by 0.5, would give us a 0.12. Great. Now we can add what's inside the pair of brackets or parentheses so that we get 1.12, and that being raised to the power 0.5. Now we move on to evaluate that which is powered to the power 0.5. So now when we compute that, we are going to get 1.0583 minus the 1. In subtracting that, we are going to get a 0.0583. That is in decimals. And I also emphasize it is crucial and important that we make sure that our decimal places are either 4 or 5 decimal places. And if we can keep our answers exact, that would be the best idea. Keep your answers as exact as possible. Now that we have that, it implies that the effective interest rate in percentage is going to be 5.83%. And note, this interest rate is lower than that of 6% because of the compounding period. This is beyond 1 year. Great then, so with that, we are going to also consider the third example. So stay tuned as we work on the third example. So in the third example, this is what we have. For an effective interest rate of 15% per annum, what is the nominal annual interest rate when compounded monthly? As before, we check the variables that are given. So we see that we have the effective interest rate of 0.15, 15% in other words. And now this is compounded monthly, implying that the I is equal to 12. So with these variables that we have, and also the variable that we're looking for, which is the nominal annual interest rate, the ideal formula to use is formula 4. So we can use either of the two from 4. Right, so we are going to use the first one. So substituting for the effective annual interest rate, or rather for the effective interest rate, we are going to have that as 0.15, and also the I is 12. And take note of the formula. This one is an amazing formula, and we just have to know how to compute it so that we are not caught by surprise. So now, evaluating what is inside the brackets or pay of parentheses, we are going to get 1.15 within the pay of brackets. Those are the curved ones. Then now we can move on to find the 12th root. So this is the same as having the 12th root, or raising that to the power 1 divided by 12. That's another way of doing it. So in doing so, we are going to get 1.0117. Now we consider what's within the square brackets or parentheses. Now we subtract that so that we get 0.0117. And remember, that is being multiplied by a 12. So multiplying that by a 12, we are going to get a 0.1406. That is in decimals. So if that is in decimals, this implies that as a percentage, we are going to get 14.06%. And note, this nominal interest rate is lower than the effective interest rate, and that is what is expected within a year. So that is the difference that we would have, and that is what we would sort of expect. So this is the approach that we take at all times. It is crucial that we understand the question first. So the question goes like this. A loan of $15,000 is repaid in the manner $P after 3 years and $2P 2 years later, $6,000 at the end of the 6th year, and a final amount of $3P at the end of the 10th year. The effective interest rate is 14% per annum for the first 5 years and 12.5% per annum compounded monthly thereafter. Determine P. So the solution. Recall from video part 10, in this same series, Financial Mathematics, we looked at 2 methods of dealing with such kind of questions. So today we'll be making use of method 1. And make sure that you post into the comment section if you want to see how we would solve it using method 2. So we have this animation over here which shows us the order of things. So this would be crucial because it helps us see and understand what exactly we are looking for and how things change from the first 5 years to the last 5 years. So in total, we've got 10 years that we're dealing with. So in the 10 years, we know that a loan was given out on time zero. That is the time the loan was issued. So the loan was given to be 15,000, and that particular loan is going to accumulate some interest and will be worth something in the future. That is after 10 years. We also know that in the first 5 years, there was a rate change. That is something that we have to take note of. And on top of that, payments were made. So the loan was actually being reduced, or the loan was being prepaid. And take note of how we solved such a related question. So in these periods, we've got the 3rd year, the 6th year, and the 10th year. All of these would accumulate interest as the payments come in, and that would help in actually clearing the balance of the loan. Right. In the first 5 years, we know that the effective interest rate was 0.14, and from the formula of effective interest rate, we can actually find what the value of the loan is at the end of the first 5 years. We do so because we know that beyond the first 5 years, the rate would change. So in the first 5 years, the value of the loan is going to be LV5. So the 5 represents the time period so that we are not lost. We are on the same page. So LV5 is going to be the 15,000 loan, which is like the principal amount, times 1 plus 0.14 raised to the power 5. And take note, this is the formula from the effective interest rate that we have spoken about. If you haven't checked it out, I encourage you to check it out because we covered a lot on this, and that is what we are going to be making use of. Right, so the effective rate is 0.14. That is the one that we substituted for. And the period is 5 years. And we're saying so because we know that this is per annum. So it is sort of compounded yearly. So our I is as good as 1. So that's why we just have a 5 over there. And of course, simplifying within the parentheses, we are going to get 1.14 raised to the power 5 times the 15,000. So another method would be to evaluate what this value would be, but let's keep it exact for now. Let's just keep it exact so that we don't start losing out on the accuracy of the values that we're given. Therefore, in the last 5 years, we know that the nominal interest rate became 0.125 per annum, and this is compounded monthly, implying that the I becomes 12 because we've got 12 months within a year, and that is the number of times it is compounded within a year. So that is the thing that we have here, implying that the LV10, that is to say, the value of the loan after 10 years, would be the value of the loan in 5 years, the first 5 years, times 1 plus 0.125 raised to the power 12. So, rather 0.125 divided by 12 raised to the power 12 times 5, because we've got 5 years in total and 12 months in each year. So that is what we would have over there. And that would give us the value of the loan. And this one we can move on to evaluate so that we get the value of the loan in 10 years. And that would be $53,783.07. And take note, I encourage you to make sure that you keep your values and the decimal places to 4 or 5. But now this is the value of the loan. There is no need for us to go that far. However, in other computations, we may do so. But in the final step, we need to keep the decimal places to only 2 because We are dealing with finance. Right, so we know that additionally, there were payments that were made in order to clear the loan. So we consider the payments made. We know that in the first 5 years, there were 3 payments that were made. Let's look at the first, or rather 2 payments that were made. Let's look at the first one. The first payment was P dollars. Now the P dollars was made in the 3rd year, implying that using the effective interest rate, that particular payment is going to accrue some interest for only 2 years in the first 5 years. That is to say, we are going to have 1.14 raised to the power 2. And that 1.14 is what we got from the first 5 years. Recall how we obtained LV5? That is where we got the 1.14 and raised to the power 2 because we only have 2 years to go. So implying that that particular payment P is going to accrue 2 years interest in the first 5 years. However, in the last 5 years or the second 5 years, that is going to accrue interest for the rest of the 5 years in the second period. So the initial amount in the second 5 years would be P times 1.14 raised to the power 2, which was a carryover from the first 5 years, times the new rate in the last 5 years. And we see that we obtained also from the time we were finding the value of the loan in the last 5 years or up until the end of 10 years. Then we had that to be 12.125 divided by 12 raised to the power 60. And the 60 comes about because we have 5 years and this is compounded monthly. And we know that we have 12 months within a year times the 5 years. And of course, we can move on to simplify this and evaluating that so that we get 2.42014p. So we have kept our answer to 4 or 5 decimal places so that we at least preserve the accuracy of the solution. We move on to the second payment made. This was 2p right on the dot at the end of 5 years. So implying that this did not accrue interest in the first 5 years because it was made at the end of 5 years. And that is being carried over to the second 5 years or the last 5 years. And in the last 5 years, that is going to accrue interest in all of the 5 years, the last 5 years, that is. So we're going to have 12.125 divided by 12 raised to the power 60. And evaluating that, we are going to get 3.72443p. So we are done with the first 5 years because there were no other payments that were made in the first 5 years. The rate changes. So when the rate changes, we know that we are shifting from an effective rate to the nominal interest rate of 0.125. And that then is going to give us this 6,000, which was made in the 6th year. And from that, we know that from 6 years to the 10th year, this is only 4 years. Therefore, we are going to have it raised to the power 48 because that is 4 times 12. And that will give us a 48. And evaluating that, we are going to get $9,866. And of course, we can preserve the other decimals because this is not the final step to 4 or 5 decimal places so that we preserve the accuracy of our solutions. And lastly, we know that there was an additional amount that was paid at the end of the period, which is 10 years. So meaning that this one was not going to accrue any interest. So 3p is equals to 3p. Great then, so we have the value of the payments at the end of 10 years. The value of the payments at the end of 10 years, when summed up together, they should give us the sum of the loan. So we are saying that the two are equal. That's why we have to equate them. So the value of the loan in 10 years is equal to the value of all the payments made in 10 years. And substituting for the value of the loan as we calculated it was $53,783.07. Now we add up all the value of the payments made. So these were 2.42014p plus 3.72443p plus $9,866.77692 plus the 3p. Now, the next step would be to group the like terms. So we are going to shift everything that does not have a p on one side so that we have the $9,866.77692 moving to the left-hand side, and the p's grouped together as well. So adding all the p's, we are going to get 9.14457p, and the value that we have that does not contain a p would be $43,916.293. And of course, we can divide throughout by 9.14457 in order to solve for p. In so doing, we are going to get a p of $4,802.44. That will be our value in our answer. And it is important to note that if we start rounding prematurely and also keeping to small number of decimal places, the answers that we would tend to get would be different. So it is advisable to keep our answers as exact as possible, and in cases where we cannot do so, we try to keep our answers to at least 4 or 5 decimal places. Beyond that, I also encourage you to make sure that you get used to your calculator and how to get the values. If not, you might be in deep trouble. With that, I say thank you for watching Numbers Simplified. And remember to subscribe so that you don't miss out on any of our future uploads. Make sure to check out all the other playlists we have so far. They might be beneficial to you, especially if you are a mathematics, statistics, financial mathematics student. And of course, I'll leave you with the following task. Find a question and post it on the related topic. Remember once again, your questions, feedback are always welcome here. Subscribe, like, and share so that you don't miss out on any of our future uploads. Thank you for watching Numbers Simplified. Remember, God loves you.